If you were to fall into a black hole, what would happen? So far, you've gotten more than tens of thousands of light years beyond our solar system. Delving fearlessly into the vast expanse of space, you have been a witness to the emergence of new solar systems and the catastrophic demise of enormous stars, events that are both incredibly beautiful and incredibly powerful. So, if this is your farewell concert, you're doing it in style. A black hole has this magnetic pull that can't be ignored. Not even light can escape its crushing gravity. The sheer blackness of a black hole, that enigmatic, endless abyss, might be the thing that tempts you or perhaps forces you to approach it. Get ready to plunge into the abyss of a massive black hole and witness the mysterious event horizon in action. Just what is contained within? Can you imagine the horrors of piloting a spaceship into a black hole? Are you going to make it or meet a brutal end? Join us as we take a voyage through a black hole and see what's at the end of it. There are a variety of holes, some large and others small, deep and shallow. Swimming holes, buttonholes, cheese holes, and bullet holes are all in the same network. Then on a different level we have black holes. The black hole gives off a creepy vibe. It hints at emptiness, provokes fears, and represents something that can ensnare us. A realm devoid of the passage of time, possessing incredible, incomprehensible attributes. These enigmatic, strange objects cram a tremendous amount of mass into a very small space. They devour everything in their path, including stars, gas, and light, due to their extremely intense gravitational pull. Scattered around the cosmos, they resemble fissures in space. You can't see them. Black holes fascinate people of all scientific backgrounds and interests. It could be difficult to conceptualize something that appears to be completely out of the question, especially when the entire concept sounds absurd. However, fresh insights and mental exercises are shedding light on them. Black holes were suggested to exist a century ago by Albert Einstein's theory of gravitation, although Einstein himself was among those who refused to believe it. Astronomers were able to identify the first traces of black holes in the 1980s. The formation of a black hole is now widely accepted as a possible outcome of a massive star's demise and fuel depletion. At first, the star's core will collapse. The next step is a supernova explosion, which is a tremendous explosion that releases mass and light into space. A black hole is formed when the remaining mass of a star is compressed into an extremely small area. One can only be produced by stars that are sufficiently massive, perhaps around 25 times larger than our Sun. A greater object's mass results in a stronger force of gravity. It follows that black holes are very gravitational. The masses of black holes created by supernova explosions are often just a few times that of our Sun. However, galactic core black holes may be packed with 1 billion times the mass of the Sun in a surprisingly tiny area. We're held down to Earth by gravity, but objects are sucked in by a black hole. Even light can't break free of its powerful grasp. Because of that, it seems black, as if it were completely empty. Keep in mind that space is vast. Travelling at the speed of light won't get you to the nearest black hole any faster than a few thousand years. For the sake of argument though, suppose you've mastered warp drive or wormhole interplanetary travel and have arrived at one of these black holes. Behold what's in front of you. Actually, not much at all. The colour black best describes a solitary black hole. You can tell it's not like the flat Acme portal holes in Roadrunner cartoons, since it's spherical when you go around it. And if it's spinning, which it probably is, because everything in the cosmos rotates to some extent, then the black hole will not be perfectly circular, but rather wider in the centre. Visit the centre of the Milky Way, which is home to a supermassive black hole around 4 million times heavier than the Sun, for a more spectacular perspective. As a result of the black hole's gravitational pull, a disk of gas and dust has formed around it, and it is now spiralling inward, like a drain. In the process of burning, the material is heated to billions of degrees by friction, which releases a great deal of radiation, as well as energy and charged particles. The scorching disk would be a sight to behold. The black hole is obscured by gas and dust, so it would probably be impossible to observe it up close. However, the black hole's shadow is a visible representation of the way its gravity distorts and refracts light rays in its vicinity. Because of how gravity distorts visual perception, the shadow looks approximately 5 times larger than the black hole. Most of the time when we imagine light, we picture photons hurtling forward at a constant velocity. However, photons are dragged into orbits around a black hole by its immense gravity. A dazzling ring encircling the shadow would be visible to your eyes, or a telescope if some of those photons were to escape. Meanwhile, the inner portion of the disk of material whirls around the black hole at near light speeds. A light source will look like it's much brighter if it's hurtling towards you, according to Einstein's theory of relativity. You can see a bright crescent on one side of the black hole if you gaze at it in such a way that the disk is almost facing you. This is because the side of the disk that is approaching you will be glowing considerably brighter. Thus, although the black hole itself is invisible, its shadow, encircled by a brilliant crescent and ring, would be visible. Scientists were concerned that the gas, dust, and charged particles erupting off the disk may mask this striking picture. Looking at the black hole from a distance, it doesn't seem too dangerous. Remember, it's merely a gigantic object, just like any other gigantic object. A black hole with the mass of, for example, the Sun, will exert the same gravitational force on you that the Sun does because mass is mass. The only thing lacking is the lovely radiation, heat, light, and warmth. It's absolutely possible to orbit it at a safe distance though. However, if you could get farther within, why would you even orbit it? The black hole is an infinitely dense point that is a singularity. However, the singularity itself is hidden from view by the event horizon, which is what we sanely and widely refer to as the black hole's surface. You have to pierce that shroud in order to go further. There is no actual physical border at the event horizon. It is neither a surface nor a membrane, it's simply described as a certain distance from the singularity, the distance below which one is unable to escape. Hey, not too big of a deal. This is the distance from the singularity at which nothing can escape the black hole's grasp, not even light itself, due to the gravitational force of the object. Too bad if you were to drop below this line and decide you'd had enough of exploring black holes. Unfortunately, things would get ugly if you fell below this barrier and decided you'd had enough. No matter how vigorously you launched your rockets, you would not be able to move closer to the singularity. You're in a jam with no hope. Although, that would not be immediate. If enjoy is the correct term, you have a brief window of opportunity to savor the experience before you meet your unavoidable end. The mass of the black hole determines the time required to approach the singularity. You can't even flinch for a black hole isn't very big. A few times the mass of the Sun is considered small. In exchange for a few heartbeats, you can explore this enigmatic region of the cosmos, one that is at least 1 million times larger than our Sun. But you have to hit the singularity. You're not given an option. Nothing can remain motionless within the event horizon. You must always be on the go, and in every one of your potential possibilities is the singularity. You're free to go across space in any direction after you're outside the black hole's event horizon. Ahead, on the left, a tiny amount of each, none at all, you have the option. But you must always journey into your future, wherever you go in space or do not go. You just can't get away from it. This common sense concept fails inside the black hole's event horizon. Your future here is about a single point, the singularity. All you have to do is head toward it. No matter which way you turn, left, up, or around, the singularity will always be in front of you. Additionally, there is a time limit on when you will reach it. You are not enveloped in darkness as you approach it. You're not alone. Light from the surrounding universe has fallen in and will continue to fall in. The intense gravity causes the light to be altered to higher frequencies, while time dilation makes the outer world appear to be expanding faster, but is still there. Not that it's not strange, mind you. The severe gravity disparities are caused by the black hole's mass being focused into a single, infinitely tiny point. The process known as spaghettification appropriately describes how you're being twisted from head to toe. On top of that, you're constricted. This compression also works on the light beams all around you, focusing the falling light into a brilliant belt around your waist. Along with the singularity, your perception of it becomes hideous and warped. There's no light at all. You can't see it because it's in the future, and you won't know what the future holds until you arrive. On the other hand, the massive gravitational disparities cause that point to expand to fill the majority of your field of view, rather than looking like a little dot. Approaching the singularity gives the impression of touching down on a huge, featureless, empty black planet. You've succeeded when the singularity extends entirely from horizon to horizon. So, what are you waiting for? We're not sure. While it would be lovely if you could inform us, nothing, not even you, can escape a black hole. Let us know what you think in the comment section below. Don't forget to subscribe to our channel and put on notifications for more videos. See you soon.